Today I would like to present to you a FESOM diagnostic thing that I work on for some time, and now I would like to invite people to actually test it and try to use it to help to develop it further. So in this video I would like to just show you a couple of things, how the diagnostic looks like, how they actually organized, and how you can change some things in there, and invite you, if you're interested, to write me an email and maybe start using it. So after you run the diagnostics, and I will show you in a minute how to do this, you actually get this web page where you have a collection of all the figures that was created during the diagnostic run. And I will just go through all of the available diagnostics that you can use right now. So let's start with this variable. And well, before that, we can actually have to say that we would like to compare two runs, right? So this 078 and 0710. And first thing you can do, you can just plot the mean temperature, and this is what done here at the level 0. But it's not super interesting, but you can do this. What is a little bit more interesting in terms of some aggregations is sea surface height variability and standard deviation in this case, and this you also can do. Then the next thing that you can do is subtract one run from another. So the first run will be your reference run, and see how the differences for different variables looks like and different depth. Right here is temperature and salinity. Then you can change the projection, so you can look at the north polar projection and south polar projection. You can compare the runs to climatology, so now you can see that it's again two panels because they are compared to climatology, also in different depths. Salinity, for example. Also you can look at different projection. There are a bunch of ice integrals, so it's for ice area, ice extent, and ice volume. Those are for the northern hemisphere, but you can do it for the southern hemisphere as well. And you can see that there are March and September also separately defined. Next thing is Huffmöller diagram. So first thing to note here is that the Huffmöller diagrams, they are defined according to the to some regions. And so you do average over the region, so you have here depth and time as axis. You can compare one run to another by just subtracting the Huffmöller diagrams. In this case, it's just only Arctic regions presented here. Or you can also compare these Huffmöller diagrams to the climatologies. Of course, climatology only have one time step, so you can basically just subtract the climatology from both runs. Another thing is ocean integrals, is mean temperature of some depth range, and in this case is a global ocean, and the depth range is from 0 to 100 meters. You can look at the depth as just at 100 meters, then you will just have to define from 100 meter to 100 meters, and you will have the mean temperature as well. And there are a little bit more regions here available. MOC is also possible. This is a global one, this is Atlantic one. You can look at the differences between MOCs, also like the global one and Atlantic one. You can look at the time series at different latitudes, and here you can see it's 26.5 and 45, but you can define your own, doesn't matter. And the last thing is vertical profiles. You can look at the differences between the runs, and here just two runs. You can of course add not only two, you can have like 5, 10, 20 runs. In this case it's only two runs, that's why only one plot will be made, so it's just the difference between runs. But you can also plot the difference between climatology, and again for the time being it's only temperature, salinity, climatologies, but you can see for each run you have this interesting difference. And there are more basins available, and all these basins actually can be used for each of the diagnostics that actually accepts basins. So this is how it looks like at the end. I just also briefly show you how you define the diagnostics. You of course don't have to run all of them. You can run only a couple of them, and you can change some settings in the diagnostics. So first of all, you just define some basic stuff that will be true for all the diagnostics. For example, here the input path and the input names and the mesh and so on. So the runs, it's important to know that they have to be on the same mesh. And then you define the diagnostics themselves. So you, in this file, this is a YAML file, you define what kind of diagnostics you would like to use. And for each of the diagnostics, you define the parameters, right? So for example, here I'm saying that I would like to use this variable diagnostic and I would like to plot temperature at these 3 depths. So you will have 3 figures at the end. And then also I would like to look at the SSH, and for SSH I would like to, the aggregation will be STD. And then I will be able to look at the standard deviation. I didn't put here standard deviation in this place because by default it's a mean, right? And similar things are can be done for the rest of the diagnostics. One more thing that would be maybe interesting is that you actually not necessarily have to look at the web page, but the PDF is also created using this this fdiag script that I'm advertising here, and in this case here the PDF is created as well. So this is sometimes easier to share with your colleagues. So that's why I decided that the PDF is also a good choice for doing the output format. But in principle, we can actually do it in more or less any output format that you have in mind. So that was a small introduction. I would like to invite you again, those who are interested, to maybe try to use it and send me an email if you are interested in using it, and if you have already some ideas about it. I will try to help with installation because it's usually the biggest problem, and hopefully we will be able to expand it and make it a nice thing in the future. Thank you very much for your attention.